Okay, so we are now moving on to this section of the module, and this is where we're really starting to focus in on what the module is really all about, which is developing web apps, what I called client-side rendering web apps, the last day, or modern in the more general terms. Two labs, an archive that you can download, and lecture notes as usual. So let's look at the actual slides and talk our way through them. So if you've done any Googling on React, you probably know some of the high level stuff, but I'm just going to give a quick background very quickly to the React framework itself, then talk about something called JSX, which was something that the React engineers gave us as a way of simplifying the development of client-side rendering web apps. They didn't actually develop JSX. I don't think it existed as a separate library, but they leveraged it and brought it to people's attention. Then I'll talk about one of the two tools that we will be using for React development, a tool called Storybook. And finally, then I'll talk about components. Components are the basic kind of building blocks of a React app, where we develop our individual components and we glue them together to give us an entire app. So it's a bit like a class, really, I suppose, if you like. As I usually do now, I check to make sure people can hear me. Yes?
Yeah.
Good. Okay, just by way of background, a lot of software frameworks, not just in the web world now, but in general, an awful lot of software tools and frameworks actually begin life as in-house projects within software organizations. And the same is true of React. React actually began as an in-house project in Instagram. And then, as we know, Facebook took over Instagram, and when they got their hands on the React, I'm not sure what it was called back then, but they liked it and they expanded on it, and eventually they open sourced the framework around 2012. And so, in a sentence, what React is a framework. At the very top there, I'm saying it's a framework for building dynamic web user interfaces. By dynamic, we mean the user can interact with the user interface, and as a result of the interaction, the user interface changes in terms of what it shows the user. Technically, people get hung up as to whether React is a library or a framework, but we needn't worry about that. A more technical statement as to what React is to say it is a single page app technology or a single page app framework. I kind of gave you an inkling as to where that name came from the last day. So React was released around 2012. Now, React was by no means the first single page app framework. There were many of them that predate 2012. And you probably would have heard of some of them, Angular being one of the most popular ones and still is very popular. Backbone was probably the very first one. But all of the single page app frameworks back then, they all adopted this model view controller pattern, which you've heard of somewhere along the line in earlier modules. Essentially, model view controller gives you guidelines as to how you should structure your code. Now, the React engineers decided that they were not going to use model view controller. So they set themselves apart in that sense. And they also decided that they were only going to concentrate on the V part of MVC, V standing for view. And of course, that's what I said in the previous slide, that React is all about the user interface. So it certainly broke the mold in that sense. The other way it broke the mold is that all of the single page app frameworks back then all followed a templating model. The templating model was what they used to code up the V part of MVC. And React also decided that they weren't going to use templating. I'm not too concerned now whether people are familiar with templating or not, but just by way of giving you just some bit of background. So they also didn't adopt templating. They said they were going to introduce some, they were going to adopt a components approach, which was a novel approach back then, but many single page app frameworks today follow this component model as well. So the overarching point is React kind of broke the mold, really. That's what I'm getting at. And the reasoning behind their decisions, I'm just documenting on this table here. Again, I'm not going to spend a lot of time on it, but essentially their argument was you got better separation of concerns in your code design. Separation of concerns is always a design principle, no matter what type of application you're developing. They also felt that because you were only going to be using JavaScript and HTML, then especially in the case of JavaScript, you had a very powerful language and it was very expressive. The templating, the frameworks that required you to use templating, invariably it meant you had to learn the syntax of the templating language itself. And it was usually not a very powerful syntax. Whereas with React, we just use JavaScript, and we know that is a very powerful and expressive language. So overall, anyway, these were some of their rationales. Again, I don't want to dwell on them. So for React, it's all about building components, not coding up templates. And it's all about the user interface. It's all about the V part of MVC. Now, that means that like the M part is still very important, and well, controllers less so, I suppose. The M part is concerned with the kind of data model backing your user interface. That is still very important, but they just felt that they weren't going to deal with it. You would have to use another library to manage the M part of your application. Now, that story has actually slightly changed. Like originally in 2012, they didn't concern themselves at all with the M part, and you had to use a third-party library to code up the M part, whereas now they're kind of extending React into that area, and you'll see what I mean by that later on. So what do we mean by a component? And I'm saying here that a component is comprised of two parts, the UI description and the UI behavior. By the UI description, I mean what is the actual layout of the user interface. And we know that if it's in the web world, then we use HTML to describe the layout, and that's still the case when we're using React. In terms of UI behavior, what I mean is how does the UI react when the user interacts with it? How does it behave? And we're going to be coding up the UI behavior side of our components using JavaScript. So it's two very well established technologies, and we've got nothing new to learn as such. Whereas, as I said, with the templating approach, you had to learn the templating syntax as well. And as well, what was kind of unique about React was that both the UI description and the UI behavior. Okay, both the UI description and the UI behavior are actually physically located in the one file. And that was quite unique, actually, because previously you kept your HTML in one file and your JavaScript in another file, and you somehow hooked them up together. But with React, everything is in one physical file. So they're co-located, or they're very tightly coupled. And arguably then there are these benefits, which I'm not going to talk on about, but we'll see hopefully these benefits as we start getting into React itself. Now, if we really boil it down to first principles, then, and it sounds overly simplified, but there are really only two methods that you use to develop a user interface using React. One of them is, by the way, the React framework is broken up into a number of modules. One module is called React, another module is called React DOM, and there are a few others as well, although these are the only two we will use. But in the React module or package, there is a method called createElement, and you would use that method to create a HTML element, a bit like we were doing the last day, but using the DOM API. The second method is a method called render, which is part of the React DOM library. And the render method you use to attach a HTML element to the DOM. Again, we were doing that the last day using the DOM API. So these are the two kind of React equivalents of that DOM API stuff. The create element takes a number of arguments. You've got to tell it what type of element do you want to create, a div, a H1, a paragraph, etc., etc. Number two, what properties you want to associate with that element. Now, in particular, that might mean what CSS you want to associate with the element. Could also mean attaching an event handler. And number three, then critically, what children does it have? Like we know HTML, when we write HTML, we have elements nested inside other elements. And you need to be able to express that nesting using the create element method of React. Here's the catch though. We never actually use create element directly, but it is there behind the scenes. If we had to write all our code using create element, then it just would not work, and people would not have adopted React in the way that the community has. But I am going to show you what very low level React is going to look like today. But from here on in, we will never see the React create element method at all, even though it is always being used behind the scenes. The other method, then the render method, we will see that. And what the render method takes as arguments, you've got to tell it what element do you want to attach to the DOM? And number two, where on the DOM do you want to attach it? So let's look at something tangible. So I've got a bunch of samples, and the samples are in this archive. So you just download it, unzip it, import it into VS Code. So when you unzip it, what you will see is the following. You see a folder like this, and just by the way now, whenever you're doing any JavaScript development, you will often have a file called package.json. So in many of the archives that I give you from here on in, there will be a package.json file. And if you download any JavaScript projects from GitHub or wherever, then there will always be a package.json file that contains kind of metadata about the JavaScript project. And in particular, if we just take a quick look at it, there's very little in this one, but in the package.json, there will be a list of the third-party modules that are required for the particular project to work. And you can see that the two that I'm requiring is React and React DOM. Now, whenever you download an archive that contains a package.json, then the very first thing you've got to do is run the command npm install. Now, when I hit return, which I won't because I've already done it, when you hit npm install, then npm stands for Node Package Manager. So it's the JavaScript kind of package manager. What this tool will do is, or what this command will do is, it will open up the package.json and it will look for these third-party modules that are required, and it will download them from a standard repository that it knows about. And when it does install them, it installs them locally inside in a subfolder called Node Modules. So if I actually opened up that, I can see that I have the React and React DOM as well, and some other ones. It actually will pull down some other ones as well. You don't ever need to know, you don't even need to look inside Node Modules. I'm just giving you this by way of background. So I've installed React and React DOM and some other third-party JavaScript modules that they require. Now, what I want to do though is to look at these samples. So it's the same drill as before. I start up my live server. In fact, this is probably going to be the last occasion when you use this, but. And according to my slides, I need to look at sample 01 UI descriptions. So if I click on that, if I click on that, then I get that. Now let's look at the code that actually generated that for me. Standard HTML file, and really the only interesting part. Okay, I'm referencing my React and React DOM third-party libraries because they're down inside the node modules, and this is my custom code here. And what am I doing? I am creating a HTML element using the React.createElement method. I want to create a H1. This is the equivalent of the CSS class. I have a CSS file here, and inside it will be a check. That's all that's in there, right? So I want to associate this CSS class with the H1. And okay, technically this is a child of my H1, but what it really means in this case is I want my H1 to have that as the text in it. Then I create a bunch of LI elements, no properties, and that's going to be the text of each of the elements. Then I create a UL, unordered list, no properties, and its children are the 3 LI elements that I've created just above it. A nice thing about JavaScript, by the way, is that JavaScript supports variable length parameters. So I have 3 parameters here, whereas I've only got 1 here for create element. But anyway, so the UL element has the LI elements as its children, which would make sense. Then I create a div, and I wrap the div as its children, the header and the list that I've created above. So you can see me now. What I'm actually doing here is I'm building up my my UI. I'm building it up gradually, and it's not until this line executes. What am I doing here? I'm attaching root element, which is this guy. I'm attaching that to the DOM. And this is the old DOM API syntax that I briefly talked about the last day. But really, you don't worry too much about it. What I'm doing here is I'm asking, I'm trying to find a DOM element that has that as its ID. And if you look up at the top here, I do have a div with that as its ID. So I want to attach what I'm constructing here. I want to attach it to that div. And so once that line of code executes, then I get all of that. So that's my header. That's my header. That's my unordered list. And if I just remove this line, and the live server will automatically reload the page in the browser, can you predict what's going to happen? Nothing gets displayed because I haven't attached anything to the DOM. It's not until I attach it to the DOM, and this is what I was talking about the last day, it's not until you modify the DOM that the browser itself will repaint the screen, if you like. So so that's very like what we were doing the last day, but using the DOM API. It's still very long-winded though. The only, well, let's go back to the slides. That's that. We're also told to look at sample 2. The only slight improvement, and it's very slight, instead of declaring all of these instead of declaring all of these variables, which I only use them once really, like what I could do is instead of that, I could actually put what it's being assigned to pull all of this down. And just stick it in there. There's kind of a general rule in programming. If you declare a variable and you only use it once, then there isn't much point in declaring the variable. Just put the whatever you're assigning it to wherever you're using it. So I no longer need this. Should still work okay, unless I've made a typo. Yeah, it still works okay. And I can repeat that process, like instead of each of these, item 1, item 2, item 3, I could just replace those here with what they're actually being assigned and keep on going. And eventually what I would finish up with is, is this. So I am just, declaring one variable, React.createElement, and I'm just nesting the other invocations of React.createElement. Again, it's quite messy looking though from a coding point of view, but I can do that. And that's going to produce the exact same output. You can study it later yourself, but if I look at 0, 2, it's going to produce the same output for me. But it's only marginal improvement. Any questions maybe just before I move on? Now, if we had to write our React code like that, though, it just wouldn't be any fun. And this is where JSX comes in. JSX stands for JavaScript Extension. And what JSX is in the second bullet point there is it's a declarative syntax for coding up your UI descriptions. What I was doing there, illustrating there a moment ago, was just a kind of a procedural syntax for describing my UI. But JSX is declarative, and it's always easier to write stuff that is kind of declarative in nature. But still, even though it's an extension to JavaScript, we still retain the full power of JavaScript, and that's kind of what's nice about it, really. We don't lose anything by adding on this JSX syntax, which we'll see in a second. It also means that I've got a really tight coupling between my UI behavior and my UI description. Now, I don't have any behavior in what I've been illustrating to you so far, and I won't have for the rest of this lecture. It's not until maybe next week that we get into adding in UI behavior. But ultimately, that's what JSX will allow us to do, to have a mixture of UI description and UI behavior in the one physical file, very tightly coupled, and that's a good idea. The thing though is that when you use this JSX syntax, it still has to be transpiled back into plain old JavaScript because browsers do not understand this JSX syntax. So what's sent down to the browser is still the kind of code that I've shown you so far. The beauty though of JSX though is that you don't have to write that style of code that I've shown you. You write your UI descriptions using JSX, and believe me, it's a much easier kind of task. The transpilation from JSX back to plain old JavaScript is again using this Babel tool, which I've mentioned before. So I've got sample 03, but I've purposefully put the word error in the name, in the file name, because it isn't going to work. And that's to reinforce this idea that browsers don't understand this JSX syntax. And then I've got sample 04, which is a kind of a JSX, a workable JSX solution for the 03. But let's look at 03 first. So my outcome now, my objective in terms of UI description is going to be the exact same, that H1 header and a list of languages. And this is how we actually write it using JSX. And this is what we will see a lot of going forward, as they say. So I'm declaring a variable, and I'm actually signing it HTML. Okay, now that looks really unusual, but that's going to be perfectly acceptable from kind of next week on, to assign. And really, this is the JSX, but as you can see, it's ordinary HTML. It'll expand a little bit and go beyond HTML in subsequent lectures, but for now, I'm assigning a piece of HTML to a variable inside my JavaScript, and then I am attaching, as before. But as I said, if I try and actually run that in the browser, then I get nothing. And if I open up my developer tools, it says there's a problem on this particular line number, and the problem is it doesn't recognize this symbol as being a valid JavaScript symbol in the context of where I use it. And if you look at the line number that it's complaining about, then it corresponds to this symbol here. So that proves my point that browsers cannot interpret JSX. So what do? We've got to transpile it. And the transpilation is inside in 04. Now, because we're just beginners, we can do the transpilation using an online tool. Well, maybe I'll look at 04 actually. Let's take it that way. So in case of 04, now in this case, I am referring to a file in the JSX, in the JS folder called 04 and all of this, post transpile. So if I go into my JS folder, and I've numbered them now so that you can kind of follow along. So I have 2 04s, you can see. I have a pre-transpiled and a post-transpiled. And it's the post-transpiled that my HTML needs to refer to. You can see on the right there, it's referring to 04 JSX post-transpiled, that being this file here. So this is what you write, okay? This is what the developer writes. And we need to transpile that code. And when we transpile it, what we get is that. And again, it's our React.create element kind of scattered all over the place, as you can see. We never need to worry about what we're looking at there, though. What we write is this form. So create my UI description and attach my UI description to the DOM. In terms of transpiling it, well, our first attempt at transpiling it is if you take that code and if I copy it, there's an online tool on this website. And if you click on the try it out, what you can do is you can paste in JSX or anything beyond ES5, really, JavaScript in here, and the equivalent ES5 will appear over here. So if I do that, then voila, here we go. So I would just copy this code, and that's what I did really. I copied what's on the right, and that's what I stuck into my 04 post transpiled. Okay, so So the overriding point now is, from now on, when we want to write any React UI description, this is how we write it. And we let Babel take care of the rest. Just going to pause for a second now. I'm just wondering if there's any questions about that.
Is there any plugin or anything that will transpile it for us without having to go open up a separate web page and so on?
Yeah, of course. So that's what we will see in 1 or 2 slides down. What we'll actually have is a web server that will be instrumented with this Babel transpilation stuff. So the UI experience is going to be much better. The developer experience is going to be much better. From a developer, you're going to be editing your files, you hit save, and the web server is going to detect the change in the file, and it'll retranspile it immediately and send it down to your browser straight away, for sure. But I'm just giving you the kind of slow approach to it there in the illustration. We will never really need to worry ourselves about Babel. It's always in the background, but I'm bringing it to the foreground just in this part of the lecture. Okay, so that's our first look at JSX, this declarative syntax for coding up our user interface description. So it's very HTML-like, as you saw. In fact, you know, it's 99% HTML. Technically, it's XML, but we needn't worry about that. And there are some very minor differences between JSX and pure HTML. In fact, we've just seen one of them, and it's probably the only one that we see throughout this course, which is when we want to assign a CSS class to a JSX element, we can't use the keyword class, because class is now a reserved word in JavaScript. Since ES6, they introduced classes in the object-oriented sense, and that's the only reason why we now use, we can't use class. So what the React team decided was that we would use class name instead, but it is the equivalent of assigning a CSS class, and that's probably one of the earlier mistakes that you might make when you're writing JSX. You use class here, but Babel will tell you pretty clearly that, did you really mean class name? And that's what you just change it to. I've said that already, and that's okay as well. Transpilation, Babel does it, and this is really to the question that you asked me there. So what do we use to do transpilation? We use Babel, and then how do we do it? Well, we can do it manually using what's called the REPL. That's what you saw there, that online tool. There's also a command line tool that you can download. And it's nice sometimes to actually see what is the raw JavaScript equivalent for some JSX, but it's just too slow, really. It's fine for experimenting. The second approach is kind of what I was alluding to there. When we will be doing React development, we're going to have a web server that is specially instrumented with Babel. And so it'll work the way I explained there a moment ago. When you do your file save, the web server will detect the change and do the retranspilation straight away. But of course, that retranspilation on the fly, that's fine during development, but obviously that wouldn't be very good in a production environment. And so there are also tools that you can use to take all of your JavaScript and JSX code and transpile the whole lot, and also do some extra additional improvements in your code in terms of minifying it and removing any white space, etc., etc. These are called build tools, and we would tend to use a build tool if we want to deploy our React application onto a cloud service. We can't be using number 2 there in a deployed React app, because it's going to be too slow from the user's experience. So 2 and 3, mainly 2 is what we will be using throughout, but we'll see 3 as well. So React is all about components, and a component. Oh yeah, we actually haven't seen a component so far. We've seen JSX, but we haven't seen a component. So we need to address that. So what is a component, or how do we code a component? And in fact, it turns out that a component is going to be implemented as a JavaScript function. You can have any kind of logic in that function that you want to. And typically the logic would be the behavior associated with that component, even though we won't be looking at behavior this week. But the important point there is that the function has to return the UI description for the particular component. In other words, it has to return a snippet of JSX. And what's also going to be nice is that we can actually refer to our components in our code as if they were extensions of the HTML syntax itself. So if you kind of look at this here, it looks like here that I'm passing, well, I am passing a component, but because I've wrapped it in the angle brackets, it looks like that this is a HTML tag that I'm attaching to the DOM. So I often think of React components as a way of extending the syntax of HTML, extending its kind of catalog of tags. So sample 5 is going to be our first look at a component. And again now, okay, we're going to, the source code will involve JSX, but it has to be transpiled back to plain old ES5 using React.createElement. That's taken as read really from here on in, but we don't need to look at the detail of it. So sample 5. Okay, nothing interesting here. I'm referring to a JavaScript file that has the transpile code, which I don't need to look at really from here on in. What I want to really look at is the source, which looks like this file here. And so, yeah, it looks like this thing called dynamic languages. I'm declaring a constant. By the way, because I know this variable is representing a React component, the convention is to capitalize the name of the variable. Just a convention though. And what am I assigning it? I'm assigning it an arrow function. So it's being assigned a function, which is what I said on my slide. And I don't have any logic in the function, but I am returning JSX as required. And when that gets transpiled, I said I wouldn't look at it, but just about to look at it. That's the transpiled version of that same code. Again, React.createElement. And if you want to prove that to yourself, all you've got to do is take this and copy and paste it into that online tool that I showed you. And what it produces is the same result as all of the other samples that I've looked at. So we haven't really progressed in that sense. But just to prove it to ourselves. Okay, same outcome. So the overriding point is to write a component, implement it as a function, capitalize the name of the variable that you're assigning that function to, have any logic that you want to, but it has to return JSX, and that's the only part of its return statement. Let's just park that for a second now and talk about the tools that we use for developing React apps. There are two tools that we will use, and they are really the most commonly used ones out in industry. So one of them is called the Create React App tool. That's actually the one that is being used in the second lab associated with this set of slides. And some of you have played around with that second lab. But the Create React App tool, as its name kind of suggests, is a tool that we use when we're developing an entire React app. And it does what a lot of tools that you've used in other modules that have a development orientation to them. It does a lot of scaffolding for you. So it'll build up a folder structure or create an initial kind of folder structure and file structure for your React project. And it does a certain amount of kind of code generation as well. Number two, it comes with its own development server that does all of the work that I was talking about there a while ago. And number three, it also comes with a tool that allows you to build a production version of your React app, which I kind of outlined there as well a moment ago. Now, we were using Create React App throughout this part of the module. The second tool then is a tool called Storybook. And whereas the first tool is all about developing an entire app, Storybook is a tool for developing individual components. So it's an entire kind of development environment for developing individual components. And that's really how we approach developing React apps, or should anyway. We kind of, first of all, identify what kind of components I need and then glue those components together to give you your app. And it's kind of nice. Some people don't like it, I'll be quite honest. Some people don't see the point of Storybook, but it is used a lot in industry. So I think it's kind of important to make you aware of it and get you some experience of just using it. And what's nice is that it does allow us to develop components in complete isolation from any other components that it might be working with in a completed app. And arguably, when you develop components in isolation, it's a bit like writing classes in Java in isolation. Arguably, you develop slightly better components. They're more reusable, the argument is. And it's also quicker to develop a component in complete isolation rather than trying to develop it as part of an app as you're growing the app. So I want to talk a little bit about Storybook. It's installed as a separate third-party module, and it has two parts to it. It comes with its own server, which does a lot of the work that I was talking about a while ago, i.e. as you're coding up your component, it will notice any changes that you make to any files, and it will retranspile them and send them down to the browser. So it has its own web server built in. And number two, then, it has its own kind of user interface that will help you to keep track of the various components that you have and how they're kind of related. This is what the user interface for the Storybook tool looks like. So when you start up the Storybook server, as I will in a second, when you start up the server, what the server does is it looks through your code base, looks for all of your component implementations, transpiles them, and then it will fire up a browser tab. And what you see in the browser tab is what you see there. On the left, it will list all of the components that are in your project individually. And those components that it lists on the left, they will be clickable. And if you click on them, the Storybook server will render the component on the right. So you can see what your component UI looks like by just clicking them on the left, and you can see them on the right. So really, Storybook is really about making sure, or helping you to get the layout of your component right, not so much the behavior side, more the UI description side, because when it comes to behavior, usually your component's behavior is influenced by the other components around it. And the whole point of Storybook is that you kind of develop components in isolation. So that's how the UI looks. List the component on the left, click on them, and you see what they render like on the right. And you do your debugging if they're not rendering properly, or if it's just throwing an error. Now, the question might arise, where does this name Storybook comes from? So it does have an origin, or what does the story mean in the context of React component development? it's actually linked to the whole area of user stories. If you've done any studying on user requirements analysis in your systems analysis and design. So what I'm saying is that a component, I'm saying here, may have several states, and each state will reflect or will impact on how that component renders. Now, rather than talking abstractly, a moment ago there, I had the dynamic languages component, which displayed a list of dynamic programming languages. Okay, so that is a component, and its purpose is what I've just said. But let's supposing we were told in the specification for that component that how the component renders will differ slightly depending on how many languages it has to display. Okay, so you're told maybe that if the component only has to render 5 languages, then it should just render them as we did a while ago. However, if it has to render more than 5, then it should only render the first 5 and include a button which the user can click. And if they click the button, it displays the next 5 and keeps on going like that. If they click the button again, the next 5 after that. So there's a little bit of, let's say, pagination built into the component. Thirdly, we're told that if the component has no languages to display, then rather than displaying nothing, it should just display a message saying no languages. We have to assume as well now here that the languages that our dynamic languages component has to display, let's suppose that they're actually passed into the component as a parameter. We'll see later on how you actually pass parameters to components. So what I've given you there, or what I was talking my way through, is a specification for this component that you've been asked to develop, okay? And from that specification, you can extract 3 different stories from it. And the 3 stories are as I outlined. And the reason there are 3 stories is because the component renders slightly differently for each case. So we have 3 stories, and the stories impact on how the component renders. Each story is often referred to as a state as well. Our component has 3 different states. So that's kind of where the name storybook comes from. And it's, as I said, it's really linked back to this idea of user stories in relation to user requirements analysis. So that's that. Now, we typically as well maybe might give a label to each of the stories. And so I've decided to use the labels default, boundary, and exceptional. You can call them anything you want to, but they're reasonably good kind of labels for each of my stories. Now, where is all of this going? Well, where this is going is that you can actually get Storybook's UI to reflect the different stories or states associated with a component. So now you can see now that my dynamic languages component on the left actually has 3 kind of subordinates parts to it. And the subordinate parts are the 3 different stories associated with the component. And again, those subordinate parts are going to be clickable. And when you click on them, then the component will render accordingly on the right. So this is really our part of component design. When you're designing component, obviously the starting point is you've got to have a clear specification for the component, whoever provides that, or you provide it yourself. And then from that specification, you start implementing your component, but you also think about the different states for the component, i.e. the different stories for it. That's kind of the development process. Now, I'll be quite honest, the vast majority of components that you will develop will only have 1 story and 1 state, but the potential to have multiple states would really be part of more real-life component development. And I'm saying that the Storybook tool realizes this fact and supports it in its UI interface. Even more so, you know, in a large project, you may have quite a large number of components. And so just rather than listing them linearly on the left, what you can do with Storybook is group the components into categories. Now I've given meaningless categories there called Group A and Group B, but you would have more meaningful categorization. And again, Storybook supports that, and it allows you in the syntax or in the code that you write, it allows you to group components inside categories. That's also kind of going to be useful to other members of your project team so that they can see how components are actually categorized. Now, the question though is, what do I have to do in order to get Storybook to display what I wanted to display in the Storybook UI? In other words, what you have to do is you have to write stories for your components. Not only do you have to write the components, you have to write stories for them or implement stories for them so that the Storybook server can actually display the kind of stuff that I've been showing you on this slide and the two previous slides. And initially, I guess the implementation of these stories is a little bit off-putting, but I'm giving you an outline of the stories implementation here. So let's see if we can step through it. So you implement your stories in JavaScript, and the Storybook library provides a special API for implementing stories. And so that's, I'm actually importing the API here. So there's a special function called stories of, which we use to implement our stories. I'm obviously importing React, and I'm importing the component that I have implemented. This is the same, that's quite similar to the dynamic languages component, let's assume, from earlier on. And I want to write some stories for it. So the flow looks like this, right? So you invoke the stories of function. Essentially, you pass it the name of the component, although really this is just a string. So it can actually be anything you want it to be, but it would make sense that it should be something resembling the name of the component anyway, but Storybook doesn't check that. So you give it the name of the component. This is just a boilerplate, so let's not worry about that. So you invoke that function, and then you chain on invocations of the add onto it. And you chain on an invocation of add for each story. For each state or for each story. And in my explanation earlier on, I just said that there were 3 different stories for my dynamic languages component. So I'm going to have 3 invocations of add chained on to my invocation of stories of. The add method takes 2 arguments. The label that you want to give to the story, which again is just a string, but give it something meaningful. The second argument is a callback function. In the callback, you can have any logic that you want to, but critically, the callback has to return an instance of the component. Now, let's not worry too much about what's going on here, although you kind of work it out. Clearly, what I'm doing here is I'm creating an array of my languages, and it looks like this is how I pass the array into my component. Again, we haven't seen this, but you could kind of imagine it working. So it must be that inside of my component, I'm able to access this array. But the key, for now anyway, it's how we write stories. And so it's the stories of function, and you chain on an invocation of the add method for each story or for each state. And the second argument of that add is a callback where you have to return, the component that the story is all about. I didn't bother giving you the detail here for the other ones, but so that's the flow of your stories implementation. And so when you start up the Storybook server, what it does is it transpiles all of this code, and it obviously imports all this stuff. And from all of this, it is able to generate on the UI, it is able to generate you know, that, what you see on the left there. That's what the storybook will do for you. So as a developer, this is the stuff that you have to write in terms of your stories, as well as the components. And as I said, it does look quite ugly, but you get used to the flow of it after a while. I mean, a lot of it is boilerplate, apart from what you put into the callbacks. And usually there is very little in the callbacks, as it turns out. You can also see there that I'm calling the stories of, in this case twice, because I'm calling it down here as well for a different component. So, you know, whether you break the, how you break up your stories into physical files, that doesn't really matter. You could have all of your stories in one file, or whatever way you want to. And in our case, I think that will probably be it. We put all our stories into one file. In terms of how you group components into categories, it turns out that if you look at the syntax here, right, the slash there is actually significant. So the Storybook server knows that before the slash is the category name and after the slash is the component. And so when it sees that in the string, that is what allows it to, sorry enough for jumping around, that's what allows it to generate this kind of output here. I don't think you will be doing that a whole lot, but just making you aware of it anyway. So that's stories, that's storybook, and we now need to go back and talk about components if we have time, just briefly, maybe another 5 minutes or so. So we want to go back to components and just talk about some of the basics of components, because the component that we've looked at up to now has just been purely static and hard-coded. In order to demonstrate some fundamentals of component implementation, I need to show you some samples. These samples are actually part of this lab here. Okay, so I think in the very first page of this lab, there'll be a zip that you download, and when you download it, what you will get is what's on the right here. So specifically, what you will get is this folder. And so if I pull that into VS Code, so let's see what's here first before I step through and start talking about components. Again, I've got a package.json, and the only thing that's different here is it looks like I'm actually bringing in Storybook and some Babel stuff as well. In a JavaScript project, there are two types of third-party libraries that you would use. There are those third-party libraries that are required by your application at runtime. That's these ones. And there are those third-party libraries that you require only during development time, and that's these ones. But again, you run npm install as your starting point, and it installs them alongside node modules. So what have I got? I've got a components folder, and I've got two subfolders called samples and exercises. Exercises are what you will be working your way through in that lab. In terms of the samples, if I just look at the very first one, the very first one is the same component. Sorry, that's not right. Where is it? Oh yeah, it is. Yeah. That's really the component that we've kind of seen so far, the dynamic languages one. For convenience, I've actually given the name demo to all of the components that I have created. I've got a number of them here. but you can see they're all called demo. That's okay, but it would be very unusual, but it's just a convenience. So I've got some sample components that I need to step my way through to explain different parts of the JSX syntax. And then the idea is in the lab, you would implement these components, because you can see they're all empty. You would implement them based on the specification that I give you for the component and by referring to the samples as an aid to your solution. What I've also got are stories, and I've split the stories up into stories relating to the samples that I give you and stories relating to the exercises that you'll be doing. I have written the stories for the exercises to spare you that kind of headache, but you should definitely look at the code and make sure that you can make sense of it. And so what you can do straight away is after you've done npm install, you can, I'm sorry, that's the other thing I want to show you in the package.json. In the package.json as well, there is a scripts section. And really what you can put into the scripts section of package.json is a kind of a shorthand for some command that you might execute regularly. This is actually the command that starts up the Storybook server. And you can see it's quite long-winded. So I've created a shorthand for it, just called Storybook. And so when I run the Storybook command from the command line, it's really going to execute this. It's going to start up my Storybook server on a particular port and et cetera, et cetera. So let's just do that. Did I accidentally make a change there? Oh no, that's okay. So if I go npm, so this is telling, sorry, the effect of this is to tell the node package manager to find the script called Storybook inside package.json and run it. And so when I hit run here now, what Storybook is going to do, what the Storybook server is going to do is it's going to essentially gobble up all the code that it finds, transpile it, transpile the ES6 and JSX back to plain old JavaScript, and then fire up a browser tab. And based on the stories that I've written, it will render my components on the left, and I'll be able to click on them. So it's going through its transpilation. And here we go. So if I just look at the, see all of the exercises are all to-dos. And if I look at some of the samples, they have simple enough, they're all static, but they're all illustrating something slightly different. So time-wise, I'm kind of out of time really. So I'm gonna have to pick up the story from here, which kind of means you can't really do that lab yet, but like I said the last day, I still think you can play around with this. This lab is using the Create React App tool, which I mentioned a few moments ago. So you can still play around with that. By all means, have a crack at that. You're not going to do any damage. Again, they're very prescriptive, but you could start it up okay and just set up the environment for yourselves.